Now let's talk about the circulation and the winds in other latitudes. We've spoken about the Hadley cell. And again, the Hadley cell, we have the rising air in the tropics, which actually produces a slightly lower pressure at the surface. Lots of rainfall in the tropics, close to the equator because of this rising branch. Sinking air at around about 30 degrees north. And the flow at the surface, which is the trade winds, which are going back from the 30 degrees towards the equator. And at the top of the convection, at the top of the atmosphere, around about 10, 15 kilometers, we have the flow from the equator to 30 degrees. And this loop, this circulation pattern, again, we call the Hadley cell. But now if we just look what happens at 30 degrees, not only does the air flow back towards the equator, but some of the air is actually going to go towards the north. This example we're showing is for the northern hemisphere, but we could say the same for the southern hemisphere. So the air which is sinking down at 30 degrees north and producing the desert regions, some of it will go back to the tropics, some of it will go to the north. So what is going to happen to that air? Well, again, this air which is moving over long distances is going to feel the Coriolis effect. In the northern hemisphere, the winds are going to be again turned to the right of the direction of the motion. So if we put this now on a global map, what we see is that in the tropical regions, say between 30 degrees north and 30 degrees south, all of the winds, we have the trade winds going from the northeast to the southeast. So basically we have here the northeast and the southeasterly trade winds taking things, the weather, the clouds, whatever in the atmosphere. Ships which are sailing will easily go from east to west. But when we go from 30 degrees, say, to the north or to the south, again, Coriolis is going to bend the air and point the winds in the opposite direction. Here it's going to be left of the direction, and we get what we call the westerlies. And this is from about 30 degrees to 60 degrees. So and this is where most of the world's population actually lives, or at least in the northern hemisphere, in Europe where we live. So between 30 degrees and 60 degrees north, the winds blow in the opposite direction. In the tropics, they're going from east to west, the easterlies. From 30 to 60 degrees, we have the westerlies. And for people who live in Europe or even in Israel, we notice that all of our weather systems come from the west to the east because of this general motion due to the general circulation of the atmosphere. Storms which are in Italy today will be in Israel most probably in a few days. Storms which are in Spain today will be in Italy in a few days. Everything moves from west to east, both in the northern hemisphere and in the southern hemisphere. So, and if we go even a little bit further, that we spoke about the sinking air in the polar regions when the Earth doesn't rotate. We still have the sinking region in the polar regions because of the very cold air. And so this air flows to the south and will meet this air which is moving north from 30 degrees. And we'll have another region here of convergence, and we get another cell. You can see these three cells, vertical cells, both in the northern hemisphere and in the southern hemisphere. If we show this schematically, we can see that we develop three cells in each, three circulation cells from south to north, and in both hemispheres. We have, again, the rising motion in the tropics because of the hot air. This flows north, but because of Coriolis, it only gets to 30 degrees. The air sinks there. Some of this goes to the north and will converge with the polar air coming to the south. And this gives us these three cells: the Hadley cell between 0 and 30 degrees, another cell which is named after another scientist, Ferrel, the Ferrel cell between 30 and 60 degrees. And between 60 and the pole, we have the polar cell. And you will notice here that if we go from the equator to the poles, we have two regions where we have convergence of air at the bottom, causing rising air. And when you have rising air, you'll produce clouds and rain. And therefore, two regions here will give us lots of rainfall in the tropics, where we have convergence, and around about this convergence between the polar and the Ferrel cells. And we have two other regions where we have sinking air, one at 30 degrees, where we have our deserts, but also at the poles, where we have very cold air. And at the poles, we really have deserts. Even though there's snow and ice there, there's very little precipitation, very little snowfall at the North Pole and the South Pole, because it's similar to the deserts at 30 degrees. The sinking air doesn't allow there to be much rainfall or much snowfall, and so the polar regions can be regarded as deserts, the same as their normal deserts at 30 degrees. So we have these three cells which go in both hemispheres, and in those cells we have two regions of convergence, the rainfall, and two regions which are very dry. Now when we look at the winds, and again schematically we can see that these different regions we have in the tropics, again the northeast trade winds, the southeast trade winds between plus minus 30 degrees. We have the winds which are going always from east to west. When they meet at the equator, the air rises up, but the actual horizontal motion is very weak. We have very calm, light, variable winds, and we call this region the doldrums. The doldrums actually mean it's very dull. The weather's very boring and dull because nothing really happens horizontally. We have rising air and lots of rainfall, but no real horizontal motion. And people who experienced with sailing in sailboats know that in the tropics it's very difficult to cross the equator because there are very little horizontal winds, nothing to push the boats along. The similar story we see at 30 degrees when we have the sinking air coming down at the Hadley cell. We have another area where the air is sinking, and then some of it goes north, some of it goes south. But at the surface, we have very calm, light winds, hot and dry because we're having the sinking and the compression of the air. And this area we call the Horse latitudes. There's some controversy of why it's called the Horse latitudes. We'll come back to that in a second. And then the winds again, which move to the north from the south, the southwesterlies in this region, and the northwesterlies, these are the regions where we have the storms going from west to east. They'll eventually meet up with the sinking air from the poles, and again, air which is moving south from the poles will feel the Coriolis force turning it to the right. So we have again a region of easterlies in the polar regions, and the same in the southern hemisphere. Air which is going north will be bent to the left, and we get another region of easterlies. So the tropics we have easterly winds, then from 30 to 60 we have westerly winds, and then from 60 to the pole again we have easterly winds. Talking a little bit about the Horse latitudes, this has been, the name Horse latitudes was given maybe 100, 200 years ago when there was lots of sail ships which were transporting both slaves and goods around the globe. And it turns out when you get to the region of 30 degrees north and south, again, there is no winds. It's very difficult to get across that region. You have basically very calm conditions. And it turns out that the horses use up lots of water on a lot of these ships, and in order to reduce the weight on the ships, horses were actually dumped overboard into the oceans. And so the sailors gave this the name of these latitudes called the Horse latitudes, which is still kept today, because of the very calm winds. And for sailboats which were trying to cross the oceans, you always got stuck in these regions, and the horses are the one that paid the price eventually. So again, to summarize this, if we put this on a map, we can see that on both hemispheres we have these three cells. We have the Hadley, the Ferrel, and the polar cells. In the tropics, where we have the meeting place of the two Hadley cells, which is the ITCZ, we have lots of rainfall. That's where we have our rainforests around the planet. Another area of convergence, again, is where we have around about 60 degrees, where we have the winds from the tropics and from the poles meeting each other. This is the region where we have most of our winter storms in the Mediterranean. In this region where we have cold polar air coming to the south, warm air from the tropics which is meeting, producing this region of convergence, and the same in the southern hemisphere, a similar area of convergence between the Ferrel and the polar cell. And right at the poles again, we have very little precipitation because the air is sinking there. And when we look at the winds again at the surface, again we have basically the trade winds in the tropics, and when we go to higher latitudes we have winds which are going in the opposite direction. Here's a nice animation to show that. So here we're actually seeing the surface winds, the wind direction shown by the arrows, and the intensity of the wind. You can see the date running in the top left. And what we can see here is that, again, in the higher latitudes between 30 and 60 degrees, we have the winds which are taking everything from west to east. If you look what's happening in the tropics, things are going in the opposite direction, from east to west. And if you look right in the polar regions, you may be able to see again, we have easterlies. So you can see the different directions of the flow of the pattern are because basically of Coriolis force. If we didn't have a spinning planet, the winds would be going straight north, south, up and down. But because we have the spinning of the planet, in certain latitude bands, the air is going from east to west. Others, it's going from west to east. And maybe another view of this is looking at atmospheric water vapor. So this is looking at data from water vapor. And you can again see here this kind of beautiful dance of what's happening in the atmosphere in the tropics. We can see here that all of this weather and all of this storms are going from east to west. And if you look at higher latitudes, things are going in the opposite direction. All because the Earth is rotating.